So the other one is similar. This time the process size is 2 megabytes and memory size 6 megabytes. So input out n will be this time. It means you can fit 3 processes. 6 divided by 2 is 3. Okay, so n is 3 in this time. And input output time is 50%, which is 0.5. P is 0.5. So when I put it to formula, it will be 1 minus 0.5 cube of 0.5. Okay. So if you multiply 3 times 5, it will be 125. And when you come back 3 digits, you can find 0.125. And when you subtract this number from 1, it is easy like subtracting 125 from 1,000. So it will be 0.875, which is 875. So it is 87.5%. Again, if you have problem about calculating this, just leave it like this. I will not cut points. And just know here, when this is a calculation to prove that when we put more process to a memory, when we are able to put more process into memory, it will increase the CPU utilization. So just 1 second. So if you put more process, it will increase the CPU utilization. So that's why in the previous one we found it's 75%, like this. And in the second one, we find 87.5%. That's why, because we put more process. Okay. So the next question is related to compaction. Okay, and the first one is write the disadvantages of this technique. When we were using compaction, I mean, after dynamic partitioning, they realize that, okay, when we, in the beginning, when we put the processes, internal fragmentation is 0, external fragmentation is 0. But after the processes starts to finish execution, there will be a problem. I was trying to say this. Just 1 second. Okay, I'm trying to say this in dynamic partition. How it was working when our processes are, for example, 2 megabytes, 3 megabytes, and 4 megabytes, and let's say 4 again. According to the size of the coming processes, system is arranging the partition. Let's say like this. So I put here 2 megabytes, I put here 3 megabytes, here 4, and here 4 megabytes. Okay, so because of that, there is no internal, no external fragmentation. Why there is no external fragmentation? Because the system, we have only one empty space, okay? So empty parts are contiguous. But think about that. This one is finished execution. So in this case, we have still two empty parts in two different places. So now we have some external partition. Not contiguous. The empty parts are not contiguous anymore. Yes, exactly. So to fix this one, they think that, okay, why we don't continuously just change the places. So when they are trying to say, why we don't just think about that. If we have some empty space, why we don't do like that? Why we don't take this process and put there? So in this case, other parts will be again contiguous. And this is compaction. The way that they are doing like that is compaction. So in compaction, we were moving the parts continuously to just make the contiguous space always. But in this case, the efficiency of the system is decreased because of this kind of transferings, okay? System is continuously transferring something, and this will affect the system speed, the efficiency. Because while in the memory they are moving something, CPU has to wait. So it is decreasing the efficiency. So this is actually the disadvantage of this technique. And another kind of question, which again I will ask in final, it is related to compaction. If operating system needs to copy 8 nanoseconds to copy 1 byte from one place to another, calculated time needed in seconds for 200 megabytes. So let me to solve this. So if 8 nanoseconds of time needed to move 1 byte, okay, it is asking me another time, so it will be below the 8 nanoseconds. How many seconds will be needed to move 200 megabytes? Okay, in this case, our main aim is to just convert the information to same units. Okay, so this is in bytes, byte. So I have to convert this one to bytes. So to convert megabytes to bytes, mega means million. So I can write 200 million. Okay. How many digits? 0 in million? 6. So I can write it like that. 200 multiplied by 10 to the power of 6. If I say you kilobytes, how many 0 in kilo? 1000. So 3 zeros. So it will be 10 to the power of 3. Okay. Here I am not using 1024 or this kind of numberings. We are using approximately, like by using the power of 10, because it is easier to calculate by hand. So on the other hand, if it is 8 nanoseconds and I asked it in seconds, so I have to convert it to seconds. So second is a bigger unit than nanosecond. Nanosecond is 1 nanosecond is 10 to the power of -9 seconds. So if it is 8 nanoseconds, it will be 8 multiplied by 10 to the power of -9 seconds. So if I ask you not in seconds, in nanoseconds, you don't need to convert this, okay? You just use this one. But because of here I asked in seconds, you have to convert and give the answer as seconds. So you have to make cross multiplication. So you have to multiply these two and divide by this. So 8 multiplied by 10 to the power of 9 multiplied by 200 times 10 to the power of 6. So the powers in multiplication can be added, okay? So minus 9 plus 6 will be minus 3, okay? And when I multiply this one with this one, it will be 1,600. So to write it in seconds, this can be simplified more. I can go 1, 2, and 3 digits to eliminate this one, okay? So if it is positive number, I mean, if this one, the power is positive, you have to go right. If the power is negative, you have to go left. So it will be 1.6 seconds. But this is very easy to calculate. But if you are not able to do it, just leave it like this. Okay, I will accept. So okay, 2 to the power of 10 is kilobyte, yes. Yes, Isaac sent me, I saw that they used 2 to the power of 20 in the slides. But, okay, let me to show you. Look. So, 2 to the power of 10 is actually the real, exact, you can find the exact result. You have to multiply 2 multiplied by 2 10 times, okay? 10 times. And it will be 1,024. One friend asked me this question. Not ask me, he says in the slides it is calculating like that. But do it like this, it is easier that I showed to you. It doesn't matter for me, but so this is 1 kilobyte, okay? So instead of that, if you multiply 1 kilobyte by 1 kilobyte, it will make 1 megabyte. Okay, so 1 megabyte is 1 kilobyte multiplied by 1 kilobyte. So when you multiply, the powers will be added. So it is 2 to the power of 20. But don't do it like that. Do it like my way that I told to you. So it is easier to calculate. Okay, I'm not going to give you kilobyte, megabytes, or powers of 2, powers of 10 lecture, but Okay, conversion. Yes, I'm going to say one of your friends said, please repeat what you said about the conversion. Okay. Look, in the equation, I am giving you 8 nanoseconds, okay, to copy 1 byte, and asking in seconds for 200 megabytes. So these values are not same. We have to convert, okay? So when I put this cross multiplication form, if 8 nanoseconds, to move 8 nanoseconds, we need 1 byte. How many seconds I need to move 200 megabytes? So because of I said seconds, okay, what does it mean? I have to find the answers in seconds. It is like that. If I say you 30 minutes, but I want answers in hours, so you have to say me half hour, okay? What did I do? I just divide 30 to 60, okay, to find half an hour. So this is similar. So I have to convert nanoseconds to seconds. And I'm not going to ask any other version of it. I mean, I will ask nanoseconds. So you have to know that it is 10 to the power of minus 9 seconds. So because of I have 8 nanoseconds, it will be 8 multiplied by 10 to the power of minus 9 seconds. Okay. On the other hand, this is megabytes. So if I need to convert this one to megabytes, I have to find some negative value, some I mean negative powers again. So it is easier to just directly convert megabyte to bytes. How? 200 megabytes. Mega means million. So you have to say 200 multiplied by 10 to the power of 6. If this will be kilobytes, you have to say 10 to the power of 3. Okay. If this is gigabytes, this is so big for a RAM, but just as an example, 200 gigabyte is maybe big servers have this much RAM. So if it is 200 gigabytes, you have to say 200 multiplied by 10 to the power of 9 bytes. Okay, so you can convert them like this. From nanosecond to megabyte. Okay, nanosecond is time. One of your friends asked me, what is the conversion from nanosecond to megabyte? Nanoseconds is time. Megabyte is, how can I say, an amount of memory. So they are different. Okay. So how many minutes we have? I don't know what. Yes. Okay, cross multiplication. Again, your friend asked me because of cross multiplication. Okay, so to make cross multiplication, I have to make the both times and both amounts same. We don't know the time. It is second, but we don't know it yet. But I have to convert it to seconds. Otherwise, I will take wrong answer. And here, look, you can convert byte to megabyte, and just you can leave it like this. I mean, let me to do it. If you try to convert byte to megabyte, so in this case, 1 byte you have to say 10 to the power of minus 6 megabytes. Okay, so if you don't want to write this, you can do it like that, but my way is easier, so I don't want to confuse your mind. We just make a conversion. It is not so hard. Also, one of your friends asked me from WhatsApp. Let me to just copy and give it to you. 1 second. Okay, in compaction, there is another kind of question. Actually, it is same, but just one thing is changed. No, this is same question. I solved it, so just applying the formula. Okay, it is same question. Okay, I'm continuing. Yes. So I picked some questions from the assignment, final assignment. Okay. I don't know how. Let me to. Okay, I will draw them again one by one. Apply round robin, and the time quantum is 2 units. Okay. That's why it will take so long. But the question that I will ask, most probably I will give 3 units or something like that, because it will take so long. So we have processes, we have burst time, we have arrival time. Normally arrival time normally is in left and burst time is in right. So be careful. If I didn't do it by purpose in the quiz, but just you can understand the difference. So 3, 5, 2, 0, and 1 is the arrival times. Okay, round robin is the preemptive version of. Let me to. Okay, I'm switching. I understood that you can see the screen. Just 1 second. I will. Okay. So in round robin, we said time quantum is 2 units, which means when it is 2 units or 2 nanoseconds, something like that, it means the processes will switch in each 2 units or 2 nanoseconds. And these are the burst times: 9, 6, 7, 6, and 3. Okay. So first of all, which process is in the memory first? P4. Okay. So I have to check in the beginning which one is arrived first. P4. So I put P4 here. Okay. P4. So how much time? 2 nanoseconds. Why? Because it is saying me like that, 2 units. So when you have to take track of the memory like this. So when you put here P4, you have to put here P4 as well. Okay. So it means it is in memory. So but is it finished? No, because it is 6 nanoseconds. So I have to put it back. But when this process is finished execution, when time is 2, it means I have to put back when time is 2. But because of there are some other processes arrived, look, when time is 2, P5 is already arrived, P3 is already arrived. So I have to put here P5, P3, and then P4. Okay, so I have to put it back. I put it after these 2. So this one is executed. Then after execution, in memory, we have P5 and P3. So I will put P4 after these 2 processes. So then it will clear that P5 will be executed. So next process is P5 because of this. Okay. So P5 will be executed 2 nanoseconds. And when it is finished execution, when time is 4, when time is 4, I have to put it back. When time is 4, P1 is also arrived. So I have to write P1, and then I will put P5 again. By the way, I wrote here 4 nanoseconds because P4 remaining 4 nanoseconds after it executed once. I write here 1 nanosecond because after P5 executed once, it is remaining 1 nanosecond. To not to confuse. Sorry, I have to close and open the lecture again because time is finishing.